Hello everyone. Welcome to last lab electrical drive. Uh, so at the end of the day, we are expect that you are able to demonstrate the operating characteristic of three-phase induction motor by using the four-pole square cage induction motor. If you look at the circuit, this is our circuit. We have variable voltage source, and E1 and E2 is actually phase-to-phase voltage, and I1 and I2 is actually your current go through phase number 1 and phase number 3, and this is the induction motor and this is the brake. What I have done the wiring of this circuit. Maybe we can move to the workstation now. This is the variable voltage source, and this is the data acquisition center, so to measure and to record the data related to voltage 1, voltage 2, I1 and I2 as well. And this is the dynamometer, and this is our induction motor. So based on the wiring in the circuit, so I have done the wiring in this part, and this is our brake. And if you look at the dynamometer screen, so here you can monitor your speed and the torque and the power as well. So the procedure for this lab is actually, maybe we can move back to this section, this one. What I'm trying to do to find the speed torque characteristic of this induction motor, I run, first of all, I set the voltage to the nominal one, which is about 415 or 420. And then what I'm trying to do, I just try to change the torque, or actually the load, and I increase the load by 0.3 Newton meter increments up to 2.1, and record all data related to the power, active power, reactive power, speed and the voltage. And also in the case if you want to see what's happened to the phase-to-phase voltage and the current as well, you can record those data. Well, this is our window, metering window, E1, E2, I1, I2, mechanical power, the torque and the power for each one as well. In case if you want to measure the reactive power, for example, you just change it to Q, and if you want to measure the active power, just change it to P, and then you will see you can record the data. By the way, so for now I just try to run the simulation. First of all, let me do the setting here. I need to record the speed as well. All right. Okay, turn the source on. Set the voltage to the nominal one. I set it to 395 something. Now I record the data for the first part, and then I just gradually increase the torque by 0.3 Newton meter increment, 3.3. I run this one as well. I record the data and I keep moving. So I increase it up to 2.1, and since we reached that point to get the better accuracy, so I just increase the torque by 0.1 Newton meter up to 3, and then once I finish, then I can plot the speed torque characteristic as well. Due to the short time that we have, so I just stopped running the simulation at this point, but the procedure is exactly the same. For the next step, I need to change the winding here to see what happened. What's the reaction of the motor to change the winding here as well. So for the next part of this lab, I just try to change the stator winding here and to see what's the reaction of the induction motor to that change. So for that purpose, I just flip those two, for example, and just look at the direction of the motor rotation as well. So I just increase the voltage very slowly to see what happens. So as you can see here, the rotation, the direction is actually anti-clockwise, right? So now let's see what happens if I change these things. So I do same thing, and again just look at the direction of the induction motor rotation as well. All right, so again. So this time is clockwise. So it means that if you change the phase here, the configuration, you can change the direction of rotation as well. That's it.